A city goes dark. Then another, and another, within minutes. Millions of homes lose power, traffic lights stop working. Hospitals switch to emergency generators. Factories fall silent, trains slow to a halt. Airports begin delaying flights, not because of a storm, not because of an earthquake, but because one of the largest machines ever built has stopped working. It isn't a building, it isn't a computer. It isn't even a single machine, it's a network. A vast web of power lines, substations, transformers, and control centers stretching across an entire nation. Together, they form the world's largest power grid, a hidden system that keeps more than 1.4 billion people connected to electricity every second. Every morning, most of us wake up and flip a switch. The lights turn on instantly, we rarely stop to think about what made that possible. But behind that simple action lies an engineering system so enormous that it spans mountains, deserts, forests, and megacities. A system that never sleeps. Electricity is different from almost everything else we use. It cannot easily be stored in the quantities modern society demands. Instead, it must be generated and delivered almost the exact moment we need it. Every second of every day, if demand suddenly increases, more electricity must be produced. If demand falls, generation must decrease, the balance is constant, and even small mistakes can ripple across the network. In China, keeping that balance is one of the greatest engineering challenges on Earth. The country operates the world's largest power grid, managed primarily by State Grid Corporation of China. Its network stretches across vast distances, connecting power stations in remote regions to cities hundreds or even thousands of kilometers away. From hydroelectric dams deep in the mountains, to wind farms across open grasslands, to solar fields in a desert, power flows through an immense web of transmission lines. But moving electricity is only part of the challenge. The real difficulty is controlling it. Imagine conducting the world's largest orchestra. Except every musician is constantly changing tempo. That's what power grid operators face every second. People turn on air conditioners. Factories start production. Electric vehicles begin charging. Entire neighborhoods wake up. Demand rises and falls continuously. The grid must respond almost instantly. To help manage this complexity, advanced monitoring systems watch the network around the clock. Thousands of sensors report conditions in real time. Engineers can detect disturbances before they become major failures. Computers help predict demand. Operators reroute electricity when necessary. Most of this happens without the public ever noticing. Yet no power grid is invincible. Severe storms, earthquakes, equipment failures, human error. Even cyber attacks have become growing concerns for electrical infrastructure around the world. A major disruption can trigger a cascading failure, where one overloaded section causes another to fail, and then another. Defects can spread much faster than most people realize. History has shown how fragile electricity can be. Large blackouts have affected millions of people in different parts of the world, reminding us how dependent modern life has become on reliable power. Without electricity, communication slows, transportation struggles, water treatment systems face challenges, businesses stop operating. The systems we rarely think about suddenly become impossible to ignore. Yet despite these risks, the world's largest power grid continues operating every day, quietly, relentlessly, delivering electricity across mountains, rivers, and cities, keeping factories running, hospitals operating, homes illuminated, and billions of ordinary moments possible. The world's largest machine isn't found inside a factory. It isn't displayed in a museum. It's spread across an entire country, working silently, every second, keeping modern life in motion. Hidden places, unanswered questions, veiled frame. Subscribe for what's next.